Hello, friends. Today we're going to be looking at parallelograms and some properties of parallelograms. Basic definition of a parallelogram is simply that both pairs of opposite sides are parallel to one another. So here are a couple of parallelograms, and I just copied one from the other, and I created these parallel lines by making sure when I drew them, the lines were parallel. I copied the line, and then I brought it down, and you can move it on the app here that I'm using to snap it into place to make sure it's perfectly horizontal. And then I just connected the two sides, right? If it's the same length. So anyway, these two are both parallelograms. They're congruent with each other. Now watch this. Since they're congruent with each other, what I can do is I'm going to take one, I'm going to flip it around like that, snaps into place. Now I'm going to put it directly over the other. And you can see that it lines up perfectly. What does that mean? Lines up perfectly like that. And then even when I put it back, I can line it up. And if it allows me to put it in the right spot, again, you can see lines up perfectly. What that tells me is that these opposite angles are congruent to each other because G matched up perfectly with M and T matched up perfectly with M when I had it flipped. So opposite angles are congruent to each other. And these two were same thing. Also, GE and OT both lined up perfectly with MA. That means that opposite sides are congruent. Okay, and so that gives us two of the properties of parallelograms. Opposite sides are congruent and opposite angles are congruent. By the way, rhombuses, squares, and rectangles are also parallelograms, and so all the properties of parallelograms also apply to rhombuses and squares and what was the other thing? Rectangles. Right, so we're going to keep track of these. The different types of quadrilaterals have different characteristics, different things that are true about them. These are true of all of these types of parallelograms. Also, the diagonals bisect each other. Right, and so we can show that by drawing some bisectors. So if I draw a diagonal like that and diagonal like that, and then I'm going to do the same thing on this other one, we're going to find, okay, and I'm going to label this middle point B on this one, and I'll label this middle point here C. Okay, now I have to group these things all together just so that I can move them all together. Good. So now when I flip this over, line it up, and again, even these line segments line up perfectly with each other, right? This segment, this means that this segment is the same as this segment is the same as this segment. Okay. Now, what we're doing here is we're kind of using an argument just by looking at these and trying to line them up and everything. It's not really a perfect geometric proof. If you really wanted to prove these things, here's how you can do it. We're going to prove it. We know that these two lines, right, opposite sides are parallel to each other. That's the definition of a parallelogram. Now, what do we know? Okay, so if we've got parallel sides, opposite sides that are parallel, that means that alternate interior angles are congruent. We know that, right? That's one of the postulates or theorems that we had from earlier. So that means those two angles are going to be congruent, and these two angles are going to be congruent with each other. Now I've got angle, 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 right? Angle, angle. Also, this side in the middle, this diagonal is congruent to itself. Now, using my triangle congruence theorems, I know angle, side, angle. This triangle is congruent to this triangle. That also means then that all corresponding parts of congruent triangles are congruent. If this triangle is congruent to this triangle, and that means this side is congruent to this side's congruent to this side, this angle is congruent to this angle. So many of those things follow in place, right? So that's two of those characteristics immediately. Also, what we could do is draw another diagonal. Let's do this one in red. It's exciting. So now, again, same deal. I know that this angle is congruent to this angle, alternate interior angles. And then now I need four, right? 1, 2, 3, 4. 2, 3. Oops, accidentally moved that. 3, 4. This side is congruent with itself. This side's congruent with itself. They're congruent to each other. This side's congruent with itself, with itself. And so we've got uh, a bunch of different things now. Again, we can prove that. Um, let's see, what would we have here? Angle, angle. Uh, so again, we know from before that the opposite sides are congruent. That means then, oh, you know what? I should put an extra line here just to distinguish. Sorry. So we know that the opposite sides are congruent, right? From what we said before. So I've got side, side, side. Triangle congruence. Same thing here, side, side. So this triangle is congruent to this triangle. This triangle is congruent to this triangle. That means that they bisect each other. Um, yeah, and I could have gotten that a few different ways, actually. But in order to prove these properties of parallelograms, we go back to using our triangle congruence theorems, parallel lines, all those different things. And then instead of just lining things up and moving things around digitally, we can actually see and prove these different characteristics, these three characteristics of parallelograms. Opposite sides are congruent, opposite angles are congruent, and that the diagonals bisect each other. So thanks for watching. Don't forget to like and subscribe and share.